Do you dream of power supplies? Okay, maybe that's just me taking my job home with me a bit too much. But in my dreams, my power supplies are fanless, easy to install, and aesthetically pleasing. But wait, this isn't a dream after all. They're called DIN-rail power supplies. Hi, I'm Amelia Dalton, host of Chalk Talk. DIN-rail power supplies, with their clean installation and quiet fanless design, can be a great solution to solve the common power supply concerns that come along with industrial and building automation applications. In this episode of Chalk Talk, Kylie from Meanwell and I discuss the variety of benefits that DIN rail power supplies can bring to your next design. And we examine how these power supplies can help with power buffering, power distribution, redundancy, and more. And before we get started, don't forget to click that link. There you can find even more information about this topic from Meanwell. Hi, Kai. Thank you so much for joining me.
Thank you, Amelia, for having me.
Absolutely. Okay, so we're talking about DIN rail power supplies today. But, Kai, before we dig into the details, what all will we be covering today?
So today we'll first go over a brief introduction to the DIN rail power supplies, what they are and what they do. And then we'll talk about the DIN rail power for industrial automation applications, and then move on to the DIN rail power for building automation applications. And then finally, we'll have a brief overview of Meanwell's DIN rail product offerings.
Excellent. So, Kai, can you give us a bit of context here? What exactly is a DIN rail power supply and how is it installed?
So DIN rail originally were promoted by European companies and it was a EU standard. And since then, it has been adopted by many other countries and including the international IEC standards. And the DIN rails are standardized mounting rails, and the specifications are usually TS-35-7.5 or -15. So the first number means the width of the rail, and then the second number means the depth of the rail. So for different applications, the customers may choose the different depths and compatible with different types of DIN rail products. And then as you can see, the installation, once the rail is mounted, the DIN rail compatible products are just snap on. So it's very easy installation.
Excellent. Now, what kind of benefits are we looking at when it comes to DIN rail power supplies?
Yes, so it's very easy to insert and remove. It just clips onto the rail. And also, when the DIN rail systems and DIN rail products are installed in the cabinets, it looks very neat. It's very clean installation with all the wiring lined up. So it's very aesthetically pleasing. And also, it reduces the wiring complexity and wiring costs because everything's lined up. And finally, all of Meanwell's DIN rail products are fanless design, so they're noiseless, and it helps a lot with the heat airflow and doesn't introduce any additional issues regarding the fan applications.
Okay, so Kai, can we take a closer look at the installation of these power supplies?
Yeah, so in terms of the installation benefits, the DIN rail type power supplies compatibility is definitely one of the biggest factor because they use a worldwide standardized rail in comparison to other types such as enclosed type or chassis mounting, where in order to use these power supplies, customers have to custom design their enclosure or their mounting solutions to be compatible with these power supplies, right? The hanging rails are arranged very neatly, but the enclosed types, they're usually not installed on any rails. They have to be mounted in a custom location. And the installation time is, I think, one of the biggest reasons why customers would prefer the DIN rail is because it's very fast. It's hands-free tool. You just snap it on. Whereas for the enclosed type, it's usually done in the factory settings or in the fields. They need to use power tools or screwdrivers and other tools to mount them properly.
So, what about the fanless design of these power supplies? I would imagine that would help a lot with noise and cooling.
Definitely, noise and cooling is one of the biggest factors. But also, if we look at the longevity and reliability of these products, with the fan cooled solutions, there are a lot of dust and moisture being absorbed into the units depending on the fan's orientation. But in a fanless situation, there is no dust or moisture purposely like absorbed into the units onto the PCB. So it reduces the dust intake and failure rate of the power supplies in general. And of course, noise. Fanless is completely silent, whereas in some applications that are very noise sensitive, customers have a lot of headaches when they have to use a fan cooled power supply. And also, because the units are fanless, they don't need to rely on airflow and ventilation to cool. The installation space can be a lot narrower in comparison to something that needs proper ventilation and cooling, like the fan cooled power supplies. And finally, in terms of the installation cost, the wiring, since the space is narrower, the enclosure, they can be closer together. So the wiring cost is also lower.
That makes sense. Now, Kai, what kind of applications would these kind of power supplies be good for?
Yeah, so thin rail power supplies are usually utilized in factory automation, and also building automation has been picking up as well. And they use a lot of thin rail power supplies. They usually even have specific mounting and specific panels designed for power supplies. And then green energy, we have customers using thin rail power supplies, external mounted control cabinets for the solar trackers, for example. And then for security and fire control applications, there are a lot of panels that use the thin rail installation as well.
So, you mentioned factory automation, and industrial automation is a big topic in electronic engineering today. So, Kai, what kind of power requirements do we need to keep in mind when it comes to these applications?
Yeah, so for the industrial automation applications, customers often have headaches or have to consider the power buffering of their application because they need some additional time to turn off the units or to save the operation state properly. And there's also redundancy because a lot of these automation are mission critical applications that cannot afford as much downtime and they want to keep them running as much as possible. So redundancy is another factor. And then power distribution, there may be many different components in a big like warehouse or factory setting. So they need to have ways to properly and cleanly distribute the power. And finally, it's the input voltage because the warehouse and industrial factory settings, they usually have different AC voltages in comparison to the home outlets that we're used to, right? So they need specialized power supplies to support these kind of input voltages as well.
That makes sense. Now, can you explain power buffering a bit more?
Yes, so for power buffering, we have shown on the slide here a basic setup where we have a AC input powering the AC to DC power supply. And then in between the power supply's output and then the load equipment, we have a buffer module in between. So what this buffer module does is it will provide a buffering time or additional energy to support the voltage a bit longer to extend the power loss period after the AC may have lost power. And in this case, so we have the buffering time is greater than 250 milliseconds, which is typically enough for the automated equipment to either park themselves in a safe location or their default position or to save the operating states. So this gives the equipment reaction time to properly shut down.
Okay, cool. Now, what is included in the redundancy you mentioned?
Yeah, so for redundancy, we want to have a backup, right? Basically, redundancy is a backup power source. So in the case of the redundancy, we have two power supplies that are both supplying power to the load. And in this case, for example, load requires 20 amps of power, and we use two 20 amps power supplies to power this load simultaneously. The normal configuration, of course, is we have two blocking diodes at the output of each. So normally only one power supply is outputting. And if this power supply fails, the other power supply is also able to supply the 20 amps that's needed by the load. So it will take over. So if one of them fails, the whole system is still operating normally.
So, Kai, what about power distribution? What does that look like here?
Yeah, so we talk about how there are different loads and many different equipment in a industrial setting. And these equipment may require different voltages. Some of them may need 24 volts, some need 12 volt, some may need 5 volt, and then some have ND equipment that have a DC to DC power supply built in that may take the 48 volt bus voltage, for example. So the setup here, example, we have the AC input power coming into the higher power main power supply that provides a 48 volt DC bus, and then we have the 48 volt DC bus powering additional DC to DC converters that will step down these voltages or regulate these voltages to the desired voltage by the load. And we usually call this point of load application.
So, what kind of input voltages are we looking at for DIN rail power supplies for industrial automation? And they vary by country, right?
Of course, yeah. So different countries around the world, they have different electrical systems and different electrical standards. So they usually have different standardized voltage. So for example, USA, we're running on 115, 110 volt AC output, whereas somewhere like China, their standard voltage is 220 volt. So in addition to that, there are also different voltages for different settings, and that's usually divided by the single phase, three phase, or dual phase utility systems. So for the three phase in the USA, we have 240 volt AC input or 480 volt AC for the three phase voltages. So it's very important to have the power supplies able to support these unique and specialized voltages for these industrial applications.
So, you mentioned building automation earlier. What kind of power requirements are included in these kind of designs?
Yeah, so we're shifting from industrial automation to building automation. And for the building automation, usually a smaller scale, but they do still require a lot of considerations in terms of the backup. As a UPS backup that's connected to a battery, they want to be able to have power access when the AC power is off. And then there's also inrush current because in the building automation space, the utility grid may not be as high current rating as the industrial setting that we talk about. And also controls is a very important factor because building automation, they want to be able to enable a efficient and flexible control scheme to the power and to the components that's powered by the power supplies.
So, what about the UPS module? Can you give me some details about that aspect of the design?
Yeah, so showing on the slide here, we have a typical configuration employing a UPS module. So we have the AC to DC power supply coming in from the 120 or 240 volt AC load line that's typically used in the buildings. And then the bus voltage is 24 volt. And then in between the bus voltage and then the downstream loads, we add this UPS module that is able to accept the DC voltage input from the primary power supply and also connects to a battery. So during the normal operation, the UPS module will charge this battery through the AC to DC power supply. And then in the case that the AC power is lost, and then the 24 volt upstream is cut. So now the UPS module will take power from the battery and then provide 24 volt DC to the downstream loads. So this is the typical UPS module setup. So we also have another type of specialized power supplies. We call them security power and the UPS module. So this single unit is able to combine the AC to DC component as well as the UPS aspect. So this single unit without any other additional modules or configurations is able to power the load when the AC power is normal and then charge the battery at the same time. And then when the AC power is lost, this single unit will take power from the battery and then provide the power to the load to provide the backup.
That makes sense. Now, Kai, can you also explain the inrush current a bit?
So for building automation applications, we usually have lower amperage rating circuit breakers. So the inrush current, when we have multiple switching power supplies, especially because they're known to have high inrush current, when multiple units are wired directly to these circuit breakers, sometimes they may forcefully trigger or trip the circuit breaker during that initial inrush setup. So a way to solve this issue is by adding a inrush current limiter That's also a DIN rail peripheral module that will help reduce the inrush current that is seen by the circuit breaker. So that will prevent the circuit breaker from forcefully tripping.
So, Kai, when talking about building automation, we also need to include sensors, actuators, and different system components as well. So, what kind of system would you suggest to take care of all of these aspects of the design?
Yeah, so control is an important consideration for the building automation. And to tie all the sensors, actuators, and the system device together, there's a relatively new standard called KNX, and it is a building automation protocol that helps tie these together via a common platform, a common language. You can think of it that way. So the sensors, the actuators, and the system device that support KNX protocol will be able to talk to each other with very minimal wiring.
Can you give us an example of KNX in a real world example?
Yeah, so KNX products cover various applications in the modern buildings, and currently the KNX standard is very popular in Europe, and we anticipate that will slowly be adopted by other regions as well. So with the KNX in a typical house setting, there are more and more types of devices that support KNX. So we have the electrical blinds, the HVAC, the lighting. There are multiple solutions and products that support KNX. So in turn, we'll have power supplies that also speak the KNX language and will be able to handle the communication and the controls from the KNX controller.
So, what kind of options do I have when it comes to DIN rail power supplies?
So this table here shows the Meanwell's product offering and the category breakdown. So for the AC to DC linear power supplies, we have a large selection of single-phase AC input power supplies that covers a wide range from 180 to 500 volt AC, as well as other series in different tiers that will cover the normal 110 or 115 and 230 volt AC input. And then we also have offerings that support more unique voltages, like the three-phase input that goes from 240 to 960 watts application. And we also have some ultra slim. So basically, we have anything the customer will need from whether it's the form factor, the size consideration, or the different power level that's required, or the different input voltages that is required for the different ACs from the different locations worldwide. And in terms of the DC to DC, we'll talk about that's used in the point of load distributions. So we have the plastic enclosure series that covers 15 to 60 watts. And then we also have metal enclosure that covers the higher wattage from 120 to 480 watts. And then finally, we have supplementary modules that enable the different considerations for the industrial automation and building automation we talk about. So we have redundancy modules that allow the connection of two power supplies and then provide power to the load and provide the redundancy backup configuration. And we also have a buffer module that can just be directly wired and hooked onto the AC to DC to load system. And then we have a UPS module as well. And we also have the inrush curve. And then for the special power supplies, we have some LED drivers that are DIN rail mounted, as well as a security UPS product family that enable the UPS setup in a single unit configuration without the AC to DC power supply plus the module. So the security UPS is just a single unit that handles the AC to DC power conversion as well as the backup. And we currently have the DRC series that cover the lower wattage application from 40 to 100 watts. And we have the newly released DRS series that covers 240 to 480 watt applications.
So, what kind of KNX options does Meanwell offer?
Yeah, so for KNX, meanwhile, we also have a large selection of different components from the bus power supply to the KNX actuators, as well as the interface modules for different languages, right? From the KNX to USB interface, or the line couplers, or the IP routers. And then we also have LED drivers that have KNX built in, and finally have a KNX to DALI gateway that can convert KNX to the DALI protocol. DALI is another protocol that's commonly utilized for controlling lighting applications in building automation.
All right. Well, Kai, this has been a lot to take in today. What main points would you like my audience to think about when it comes to DIN rail power
Yeah,
supplies?
so when choosing Meanwhile as the DIN power supplier, first of all, Meanwhile, we have very good brand awareness. We're a global, well-known brand, and we have transparent product information on our public website, and we set up regular campaign marketing projects to let the customers know of our newest release products. And then, meanwhile, we also offer very complete channel service. We have a very wide global network that users and customers are able to source all of our standard off the shelf components from. And most importantly, meanwhile, we have a complete DIN product line. We cover products from 10 to 960 watts, and we have AC to DC, we have DC to DC, and we also have KNX control products as well. And lastly, it's the worldwide certification. So Meanwhile's standard off-the-shelf products are certified to these various standards worldwide. That the most basic of all is the information technology equipment, IEC EN UL 62368-1. We also have the UL 508 for control cabinets, and then the UL 61010 is for the UL PLC and control cabinets applications. And finally, we have some products with the EN 61558-1 certification as well. And additionally, some of our products also carry specified local certifications such as BSMI for Taiwan, RCM for Australia, New Zealand region, and then EAC for the Eurasian countries.
Excellent. Well, Kai, I think that's all I have time for today. Thank you so much for joining me.
Thank you, Amelia, for having me on the show.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Meanwhile. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EEJournal.